Hello, and welcome to another walkthrough in the Python Fundamentals series. This is Module 2. We are focusing on lists. Lists are a data structure that holds data primitives like strings, integers. In fact, it can hold other data structures like lists, but it holds them in a sequence, and that sequence has special properties. We've been learning about iterators, and we know that since this is a sequence, it will have all those capabilities of iterators, which is cool, means we can use the for in loop and things like that. So let's dive in and find out about lists. We've seen them a little bit already, and so perhaps you'll recognize some of these elements as we go. So to begin, to create a list, there are actually some fairly straightforward things you can do. And among those things, you'll notice here, if you want to initialize an empty list, you can actually just name a variable, use the equals sign, and then 2 square brackets. And that creates an empty list. If you wanted to create a list with a bunch of values in it, in this case we're making a list that's full of integers, then we could use the square brackets and then just separate each value with a comma. And what happens is in memory, Python will create a space to hold the list itself, and then as each value gets put into the list, it puts them in order in a sequence. And you'll notice too that it doesn't have to be all integers. We can actually make a list, a mixed list that has, say, a couple of integers and then a couple of strings and then a float here, and it could actually include a variable inside the list, so that particular variable could be another list, as indeed here if we had already created sample list it would be. So a list can hold all kinds of things, which is super cool. If you're starting to imagine a list and you're wondering, well, how would this ever matter? How would it be used? You can think about an online store, for example, where you've got a product, and that product may have several characteristics. It may have a size, which would be an integer. It may have a color, which would be a string. It may have some other characteristics like fabric type or etc. that might actually refer to other variables that have further characteristics. So you can imagine for a specific order within an online store, you might use a list to track the exact selections that a shopper made for a specific line item on their purchase. And so these kinds of data types are really cool that way. So let's see what it looks like. If we come down here and we start to make our own list, in this first example, we're creating a list of foot bones. So if you look up foot bones, you'll see that we've got a bunch of different foot bones, and we put them all into a list. And so here we can go ahead and run this example, and we see that when we run the type function on ft_bones, that it tells us it is a list. And then when you just use print on this variable, it actually prints out all of the values in the list. So if the list isn't too long, that's fine. Then we don't have any trouble. Of course, if you had a list with thousands of values, this would start to get really difficult to go through and figure out. But we didn't have that problem here. Another sort of example we see here, review and run. So here we can have let's say we have an age survey, and these are all of the results that people gave us. And so we can go in here and we can see all of the results, and they're in order. So I would guess that the different people responding to the age survey, the first person was 12, the second one was 14, and so on. And then down here, we can see a mixed list. So you can see here we've put the age survey and the foot bones variables, which are lists themselves, into the mixed list, and we print the mixed list. And notice that it shows notice there's a square bracket whenever it shows a list. And inside of one list, we have a nested list, because this other list right here, the foot bones list, so if we go from that square bracket to this square bracket, we can see that item number, let's see, it would be 1, 2, 3, 4, 5, 6. The sixth item, which is at index number 0, 1, 2, 3, 4, 5. So at index number 5 of this list, we actually have another list, and similar index 6, because we have the age survey. So I think that should give you a pretty good sense of how to create a list and how you can tell if something is a list by using the type function, and then how to see the values in a list, all of them, by printing them. So I think you're ready for task 1. So you'll just create a list. When you create it, put 3 to 5 names in there and then print it. And then go ahead and create a mixed list that includes some numbers and some strings, and that's up to you. Just to try it out and see how it works. And you can play with it if you want. Now, let's go to another thing. So list access. How do we get to specific items in a list? So as I mentioned up above, a list is a sequence and it's iterable. So we can use all the iterator operations we learned with strings on a list, which means all the elements in the list are indexed from 0 to however many items there are, which means we can use these square brackets and find a specific item in the list. And you'll notice in the example here, FT bones with the square brackets and the 0, and that's going to find the first item in the list. FT bones with a 2, remember we're counting from 0, so that's index number 2 is the third item in the list. And then a -1 would find the last item in the list. Now the last item in the bone list, just to review, was medial cuneiform. And so let's run it and see if that's what we get. And sure enough, medial cuneiform shows up. Now, did you see the little note here? It said run previous examples before running the examples below. Why? Because running them puts the results in memory available to the code below to use. That's really important. So I had to have just run these examples up above in order for this one down here to be able to identify foot bones. Let's say I hadn't done that. Watch this. I'm going to go ahead and I'm going to restart the kernel and clear the output. And when I do this, it's going to clear out what was in memory. So now if I go up here on these examples, I don't see that they've been run. It's blank right here. So now if I try to run this, I'm going to get a name error because it doesn't know what FT bones is. And if you see that, it means that you haven't run these examples up above. So now I've got to go run these. So I'm going to go ahead and run these, and I'm just clicking Command Return. And now if I come down and run this again, it works, because now this FT bones list is in memory waiting to be accessed and used. And here I can go ahead and do another example, and we can see that it picks up the index number, it knows which item, and then it prints it to the screen. And you can start to imagine here ages. I can go ahead, because these are integers, I can actually add them up. And so we can see age survey 0, 1, and 2 all added together is 38. And if I go back up here, here are the values for 0, 1, and 2. So 12 plus 14, 26 plus 12. How about that? 38. So it's working. So I think you're ready. You're ready for this one down here. And now create a list, streets, that lists the name of 5 streets, name strings, print a message that there is no parking on index 0 or index 4. So you're going to write a little sentence kind of like the way this one was done, where you use index 0 and index 4 in the print string that you put out. And then create a list, num2 add, made of 5 different numbers between 0 and 25, and then add them all up. And that I think you'll be able to do okay. And then fix the errors. So if you run this, so review and run, but do not edit this code cell. Fix the error by only editing and running the block below. Okay, so I'm going to run this one. And the error is paychecks is not defined. So how do I fix this? Well, looks like I have a name error. We talked about that earlier. If you go here and you define paychecks and you define at least 4 items, so you need integers in 4 different values that you define right down here, and then run it so it's in memory, and then run this one again, the name error will be fixed. So I think you got that. All right, now what's cool is we were just talking about accessing lists, but we can also, we have some special methods that give us the ability to do some cool stuff with lists. And one of those is the append method. So what an append does is it adds another thing to the end of a list. So you can see here, if you already had, say, party list defined, and then you use this append method, and remember, a method is like a function definition but specific to an object type, and a list is an object type. So append works just with lists, and so we can go in here and hit dot append with parentheses and then put a value that we want to add to the end of the list. And so if we have a sample list 1 2 3, and then we append a 3 to the end, so actually 1 1 2, and then we append, we're going to see that when we print it the second time, the 3 is now at the end of the list. That's pretty cool. It's just a quick way to put another thing on there. So you can think of like a cash register where you're getting a bunch of numbers and you're adding them up, and you want to just put stuff on the end and add them to your list. Frequent sort of thing like with a shopping list, etc., where you're just adding one more item onto the list, or maybe it's a bill of sale. But this kind of data structure makes that easy to do, and this method especially makes it easy to do. Another example, so here we can append, so we can grab our sample list from before, and when we append a 3 and then an 8 and then a 5, and notice each time it is part of the list, so it just keeps going. And if we run this cell again, watch this, and again, and I'm just running the same cell over and over, and notice it just keeps building it up. So very quickly we have a lot of power to build up data and to then manipulate it, save it, move it around, use it elsewhere, etc. And similarly here, mixed types, and we can do the same thing. So I can run mixed types, and if I were to come up here, this one, because it redefines mixed types each time, it's not going to keep building it. So if I were to comment this part out and then run this example again, you'll notice I can keep adding to the end of the list over and over and over. So pretty cool. Let's see here. Append, so currency values, create a list of 3 or more currency denomination values, and the name of the variable we want the list in is cur values. The underscore contains coins and bills, so they want some floats in there. Print the list, append an item to the end, and print the list. I think you can do that. Create a list of 3 or more currency denomination names, names of coins or paper bills. So penny, etc. Got that. You can do that, no problem. Append items to a list with input. How about that? Maybe we should take a look at this and imagine what it is. So earlier we had foot bones, right? And well, let's see. Sample list. We'll just use sample list. So let's say I come down here and I say, let's just try this out. What if I say sample list dot append input, what do you want to add to this list? Like that. And then down here, what if I print sample list? Now, did I get sample list right? I did. Okay, so let's run it. What do you want to append? A new item. And did it work? So I was able to put this input into the append. So it's going to use this function, then it's going to send the result to the append, and then it actually put it onto this list and it printed the list. So I kind of gave it to you there, but play with it, try it. You can do it. And they're saying, up here that you can run it with currency names. So try it with currency names. And you can add something in there and see how that works. It looks like you can do a while loop with an append as well. So we learned about while loops already. So you define an empty list. We know how to do that. We just use the square brackets, equals square brackets, get user input for B day, ask the day of the month they were born, or Q to finish. Use a while loop, while user not entering quit. Okay. Append B day. So I'm actually going to write this one out for you because I think while loops sometimes are something new to think through. So if I do B day survey equals a bracket, and then I do while B day is not equal to Q. So we don't want it to, actually it said quit, so I'll do the whole quit. Well, actually, B day dot starts with, how about that? So B day starts with Q. Equals false. So as long as the B day doesn't start with Q, it's going to ask them to fill up B day. So B day equals input, and here's the prompt. So I can go ahead and put this here. That's what we're going to ask for. Give day of month you were born, or Q to finish. Now notice this Q here, we got to put an escape on here. Everybody remember that? And let's see, Q to finish. And then while loop, not entering quit, append the B day. So B day survey dot append B day. Okay. And then after the loop is done, we're going to print B day survey. So I'm going to run it. Oops. Did I get my slash the wrong direction? Maybe. Oh, B day is not defined, so let me come back and define B day. Start with B day equals a blank. That way it will check, it'll be able to check it here. So notice the while loop was trying to pick up B-Day, and oh, false has to be lowercase. All right, and so let's say I put 23. Oh, B-Day, did I spell it wrong? I did. A little dyslexia is getting me. There it is. Run it again. 23. Now I can do 45. I don't like how this has no space, so I would rather do like that would look better. That's a better... That won't change until next time. And then if I put in Q, it quits and it shows. Notice it did append the Q down there. So if I really wanted to, I should get rid of that. But that would take a little bit more logic. And then if I come back here and run this again, and this time my prompt looks a little bit better. And if I type in the whole word quit, it still quits the loop. Because as soon as whatever is in B-Day starts with Q, and this is the test, right? It's testing if it starts with Q. So as soon as that is true, this loop is going to end. As long as this is false, the loop will continue. So do you see how that logic works? B-Day.starts with Q is testing, does B-Day start with Q? As soon as that condition becomes true, the loop will end. Until then, as long as it is false, the loop continues. And so that's how that logic works. So do work through that, run it yourself, and then you can enjoy it. It's actually pretty cool. Fix the error, so we got to see the error. Index, list index out of range, so it's trying to grab, we have 3 numbers, but look at the index. There is no index 4 here, because remember we start counting from 0 with indexes. Remember that punch card. So how would you fix this? Well, probably need to refer to an index that actually exists, like 0, 1, or 2. So I think you can fix that one. There are some things we can do with lists. It's kind of cool. So one thing we can do is we can modify a specific value. You can see here like party list 2. So if we have a party list and we're inviting Joanna, Alton, and Tobias, and then we decide instead of Alton we want to invite Colette, notice you can do a specific index number like index 1. So 0 is Joanna, 1 is Alton. And then you can put Colette right in there. So let's test that. And sure enough, we swapped out index item 1 for Colette. So we took Alton out and we replaced with Colette. And then down here, we can also do party list 1 equals party list 1 plus DeRosa. So let's do that. And so now we can actually take whatever was in there and we can add on more values to it. So there are ways we can modify a list that's in memory. Down here as an example though, if we run this one, we see the same old problem, party list 3. Remember there were only 3 items and indexing starts with 0. So 0, 1, 2. There is no item 3. So if you're going to refer to item 3 here, you've got to have an item 3. So that's the same problem we've seen before, just coming back, because it's hard when you're in the middle of programming, you'll forget that, and you got to then know to think of it. And so practicing it helps. Review and run example changes the data type of an element, replace a string with a number. So for example, if you had a bunch of stuff here, and you wanted to make, single digits, replace string with an integer. So here we want to change 0, 1, 2, 3, and we want to replace that with an actual 3. We can do that. Okay, so if we know how to go ahead and run an example like that, and we can see that we can go ahead and take, notice single digits 3. So we printed out the whole thing. So here we can say, okay, item number 3, or rather index 3, which was 0, 1, 2, 3, and it was the word 3. And so then down here we actually replaced it with the number 3 and changed it to an integer. So we can do that too. If we go down, create a list. So this is create a list named 3num containing 3 single-digit integers. You can do that, print it. Check if index 0's value is less than 5. If it's less than 5, replace index 0 with a string small, else replace. So that's just an if and else with a condition. You can do that for sure. The function challenge, this time create a function called string replace. It takes 2 arguments, the index, int list, and index. That's the name of the parameters in the function. So when you define it, remember the def statement. Int list is a list of single-digit integers. Index is the index that will be checked. And then function replicates purpose of task, replace items in a list above. So we're basically turning all of this into a function, and it's going to return the int list. And then you test it. So you go ahead and create the function and then call the function, right? You have to actually create it and then call it. And when you call it, you're going to define your variables and input them as arguments. When you define the function, you make the parameters, and when you actually call it, you put stuff into those, and at that point we reference those as arguments. So that's what you need to do here. All right, I think you can do that. That'll be your challenge, to kind of put together a bunch of stuff we've been doing and see how that works together. Keep in mind too that what we're really learning is how to build more complicated code structures that can do more important, bigger things. And so in the case of working through like a cash register example or an online store, it's not unusual that someone will change their mind about their order, and so you need to quickly replace something, or determine that if they put in European size 42, that's actually an American large. And that's where that kind of replace methodology would start to matter in a worked example. So that hopefully that helps you make sense of how these things start to matter to actually inventing new kinds of capabilities with code. Create a list, 3 words, so it's another task, 3 different capitalized words, print all 3 words, modify first item in the 3 words to uppercase. Oops, sorry. Hit return, I just clicked into that. To uppercase, modify the 3rd item to swap the case. So all this swapping case, remember we have a cheat sheet. So if you can't remember the different options for strings, you might want to pull up our Python cheat sheet. So I can go ahead and pull it up just real quick here and remind you, on our Python cheat sheet, on the first page, you had a bunch of built-in functions, etc., but then when you got to the second page, so let me squeeze my screen down a little and move it where everybody can see it. We have these string object methods, the popular ones. And notice there were list object methods here too, but the string object methods. And so you can see in here some of the things you might need in order to make the changes you want to do. So just think through how you can use these, and I think it will help you solve the problem. There are a lot of options in there. All right, so another thing we can do with a list is we can insert. So notice here, party list.insert to Tobias. And there are a couple of important things about insert. So we already know that we can change a value itself by using the square brackets. So if we wanted index 2 to be Tobias and index 2 already existed, then we could do that. We could actually, and we did do that already. But here, when you use insert, it's actually going to open up the list at that place, 2, index 2, and it's going to put Tobias in. So let's run the examples down here and see what's happened. So here, if we see the original list was Joanna, Alton, Tobias, and what did we have? Index 1 was Alton. Index 2 here is Tobias. That makes sense. Then we ran party list.insert, and at index 1 we put Colette. So what did it do? It pushed Alton and Tobias further out, and it inserted Colette right into the middle. So insert's kind of cool that way. I think you can run task 10. I think down here, let's see what the error looks like. So here we've got a string object has no insert. Look at this. Tree list was defined with a string, quotes. It was not defined as a list. You have to have square brackets. So think about how to fix that, fix it, and then you'll have this working. Finally, we can delete things. So there are different ways to delete things, and they do different things. The oldest is the delete function. Or in this case, it says a statement. So unfortunately, because Python is an old language, some of the really old ways of doing things still exist. Most of the time we can use methods like this .pop or .remove or .insert or .append. Those are the more modern ways of writing it. But sometimes we'll encounter old ways of doing things. And so this del keyword statement is one of those. So it doesn't quite work the same way. You have to put the keyword in front of a list. So if we say del party list index 2, let's see what happens. So I'm going to go ahead and run this example. And before, I had 21 at index 1, right? But notice here, del sample list 1. It deleted that one item, and then it reproduced the list. So that makes sense. It's sort of the opposite of insert, but it just operates. The syntax is different from the way insert is written, but it's the opposite. It does the opposite of insert. And so it allows us to take an item and take it off of the list. And then you can notice we've got some other things going on here. So again, here we can get rid of the first item in the list 2 by choosing index 0. Another thing we can do is we can come back, and so mixed types, we can append a 3. Here's a 3. And we could delete an item from this if we wanted to. So we'll see some more about that later. I think you're ready to use the delete statement, so you should be okay. You can follow those two examples. Pop is kind of cool. It deletes the last item in the list by default. So if you just run pop, it takes the last item. If you give it an index number, it will take that item off of the list and return it, which allows you to put it into a variable. So you can see here, if we start with the party list with Joanna, Alton, and Tobias, and then we run pop, it will take the last item, Tobias. And then we run pop again, it will take Alton. And then we run pop again, it will take Joanna. And finally, we're going to have an empty list. Look at that, empty. So it takes the last item off of the list and it returns it so that you can do something with it. And the list itself gets modified. And so we can also pop a specific item, index 3, which is 14. So let's see how that works. And so our 14 disappeared. because we gave pop a specific index. So you can work through all these examples and you can see how they work, and notice we can use it to do some math. So we've got a few different possibilities there. I think you're ready to use pop. This is important too. So an empty list is false. So if you were to run while dog types and pop, when dog types becomes empty, it will be false and the loop will end. Look at that. So it automatically went through all the items and sent them back through print, and then it ended the while loop for us. That is pretty cool. So that's important. That'll come up again in another place. And so keep that in mind. You'll need that for an example later on. I think these two, the cash register, I think you're ready to do that. Remove is a little different. So remove removes the first item that matches. So this is a way to find something and take it out. So if we do a remove dog type, so if I run this down here, and we can see it says remove pug, and it only takes out the first one. So if we had 2 pugs, so down here if we run it again, notice we still have, it removed poodle, and then it did it again and again and again because we had a while loop. So each time it only took out the first one. Then it took out this one, and then it took out this one, which notice became that one. And then finally it took out the last one, which was the only one left. And then the loop ended because there were no more. While poodle in dogs. Look at that syntax. Isn't that cool? Because eventually there was no poodle left in the dogs list, and so the while loop ended. So we were able to tell it to just keep processing until it's done. Here you can see review and run, change to lab to fix the error. So I think you can do that. And then finally task 16, which I think you can also do. So this has been a great walkthrough to get you used to and capable at using lists, and enjoy that. These are a complex data structure that allows us to hold a bunch of data primitives like floats or integers or strings, and gives us power to start doing really important, cool things with Python.